My name is Alexander Perez, and in this video, I'm going to be going over the process of exporting G-code from Fusion360 and importing it into the Carvera controller. Okay, and now that we are in Fusion360, I'm obviously not going to be teaching you how to make a CAD model. However, I hope you have a coherent file that you can use to follow along with this tutorial. In my case, I already have a pre-made model that is very relatively simple. It's just a hollowed out epoxy rectangle, which I will be using the CAM software to set the toolpath to mill out all of this stock. So now we can switch over to the CAM section of Fusion360, where essentially we're going to be setting the instructions for the machine, as well as the direction of the material on the bed of the machine, and the direction of the end mill. So first, we're going to be going to the setup, as obviously we can't have a G code without setting up some sort of base for things such as the tool orientation origin, where we're going to be telling the machine where the X, Y, and Z of our stock is. You can put this on the top left or bottom left of your stock. I preferably like to do it on the bottom left. I just think it looks cleaner, but it's all up to your preference. And as for the machine, if you're using the carbide, you're going to just select no machine, and later in the exporting process, there will be special settings for that. But if you are using the Carvera machine, you will just select the Carvera after importing the files from the Makera website onto your computer. And as for the WCS, we just sort of leave that as is. The stock should be relatively the same, and all of that should be, left as is. For the stock, this is really depending on your CAD. In my scenario, the model I have is already set to the exact size of the stock I have in real life that came with the Carvera machine. So we can just set this to 0. However, if you are going to be using a CAD model that isn't set to the exact size of your stock, which typically it isn't, you're going to want to do fixed size box in these settings here, and then set the X, Y, and Z to the exact diameter of your stock. But yeah, like I said, in my scenario, we're just going to be setting that to 0. And as for the part position and post process, you can leave this as is. It really isn't worth the trouble to mess with it. And it's all stuff that is very finicky and very situational. So now that we're done with our setup, we can move on to the actual toolpath. And as you can see here, there's a 2D and 3D option. In this case, we're going to be doing the 3D. However, the 2D is also very useful in a lot of different other projects where there are different niche presets such as threading, engraving, and slotting. So very useful things, but we're not going to be using that today. Here in the 3D tab, you can see there are a lot of preset toolpath settings, such as contouring, using spiral, radius, different things that utilize the 3-axis machining. So very useful if you are going to be doing different organic surfaces, such as curves. But in this case, we're just going to be doing pocket clearing, as we're going to be focusing on just removing large amounts of stock without having too many different movements. Adaptive clearing is also very relevant, but pocket clearing is typically used more for just removing stock, while adaptive clearing is used for removing stock while also having a different obstacles in its way. So just sort of a more complex version of pocket clearing. And now that we've selected that, we have all of these different fun terms here. While it may look complicated, most of these things for the feeds and speeds, you can look up online. I will have a link in the description of this video showing different presets for the feeds and speeds based on the tool bits you're using, as well as the stock material. So all those things can have a factor in the efficiency of your toolpath. And doing the right feeds and speeds can help you create more of a perfected toolpath. However, most of the preset feeds and speeds will be pretty efficient, and you will not have to mess with them too much. As for the tool we're going to use, this is very situational, and I will have a separate video explaining all of the different end mills and what they do and when you should use them. In this scenario, I imported the tool files from the Maycaro website, which I will have the link for that as well in the description. But I'm just going to be using a 1.5 millimeter diameter, 8 millimeter flute end mill, flat end mill. So we can select that and put that in here. So now that is there, we can have the preset for our stock material. In this case, like I said, I'm using epoxy, but if you're using a hardwood or a plastic or a different material, you can do those accordingly. So now that we've selected that, we can move on to geometry, which is pretty simple. Rest machining is essentially going to be setting the area of the stock that wasn't previously machined by another operation. So if you have more than one operation, you should be using rest machining. But if it is just going to be one big operation such as this one, you can just set it as off. And for the bounding, the machining boundary, it should be set to bounding box. And if it's not, please select that. As for the heights, this is going to be essentially where the spindle goes to every single time it goes up. Off to, how we said that. And here we have our heights where we can see there's the clearance, retract, top, and bottom heights. The top and bottom heights should just be set to stock top and bottom. While the retract and clearance heights are very specific. If you're going to be using a stock that has different lengths up and down, you should set the retract to a lot higher than the top of your stock. In this scenario, it's just going to be one flat length. So we can set this to a smaller clearance and retract. However, if you, like I said, are going to be having different size stock, you should set your retract higher, just as sort of a safety precaution. And yeah. Now for passes, this is also a very important tab that can affect the way your toolpath is generated very heavily. The tolerance is a very, very important setting. It's essentially deciding how much of your milling is going to be smoothed out. So in this scenario, we're just kind of be cutting straight across. There's not a lot of curves or things like that. So we can just set that to 0.3 just to more efficiently clear the stock. But if you are going to be doing something more detailed, I would suggest a stock such as like a 0.5 or even 0.7. And as for all of these settings, these are pretty self-explanatory. If you look at the preview, they're also kind of irrelevant, so we can just sort of ignore those. For the direction, in this case, we're just going to be climbing down the stock here, so we can just leave that as conventional or both ways. It really does not have too much of an impact. If you are going to be doing a more complex toolpath, I would suggest doing both ways. But yeah, really not that important unless it is a situation that requires it. For the smoothing deviation, this is essentially how much your corners are going to be avoided. Because we're also using a circular bit or end mill, the corners will have a little bit of stock left on them, and that is called a fillet. And if you so choose, if you're doing a project such as this, you're going to want to most likely have a separate toolpath with a smaller end mill, or an end mill with a smaller diameter, just so that it can clear more of the fillet and have a more accurate angle there. But in this case, we can just leave that at 0.1 as it is not that relevant here. And for the roughing step down or the dock, the depth of the cut, this can really be set to anywhere near 1 to 3, depending on the diameter and length of your bit, as well as the material. So if you're doing a very rough material, a very dense material such as a metal, you're going to want most likely a smaller step down as there's going to be more strain on your bit. Also, is it just sort of good token of advice? Even if you feel pretty confident, for example, that epoxy is like softer, so you can say, oh, because this material is softer and I'm using a larger bit, I can have a a 4 mm step down, that still is kind of risky and can put a lot of strain on the bit. It's also important to note that you don't know how much a bit has been used and you don't know how old it is. So generally just being patient and doing anywhere from a 2 to 2.5 step down, I would recommend when just clearing mass amounts of stock. But obviously, if you are using a much larger bit, this can be set a little bit higher. And as for the stock to leave, this can just be left as it is because our stock is kind of just literally set to the size of this box. We can just turn this off and ignore that. And yeah, that is the setup. All right, and as you can see here, we have our finished toolpath. Uh, as you can see, it is pretty simple as we are literally just going back and forth and clearing out large amounts of stock. And in relation, we have our machining time here in the corner. An hour 16 is pretty normal as we are just kind of clearing out a large amount of stock while also being careful and knowledgeable about the restrictions of our bit and the feeds and speeds. So I would say that that is pretty good. But now that you are done having your toolpath being made, you can come here and right click, or you can go to the Actions tab and go to Post Process. And here is where you can name your file. So here we can just name load out epoxy rectangle. And now that that is like that, and we have our post processing up here, we can go and make sure that everything else is fine. We have our units here in millimeters. That's very important. If you made your model in inches, obviously set that to inches. But in my case, we did it in millimeters, so that is the option I clicked. If you wish, you can post it to the Fusion team, but it's really up to you. And then now you can post it, and that should be relatively it. And now, once you go to your desktop, you can go and search it and then move it to your desktop, just so that it is a little easier to find and you don't have to go searching through your files. All right, and now on to calibration. So for the Nomad machine, this one is a lot more traditional and I guess less technologically advanced than the Carvera machine. However, still works just as well. With the door being open during the calibration process for the Carbide Nomad, we're going to need the bypass key so that the machine allows you to jog the spindle without its stopping. So here is the auto Z-probing device for the Carbide, and essentially what this does is with the metal rod that is placed where the bit would normally be, it's going to go inside the sensor and sort of hit around just to see what level things are at so it can get the X, Y, and Z axis. Obviously, like I said, this is a lot less technologically advanced than the Carvera. However, manually setting the X, Y, and Z does help a lot in the accuracy of your toolpaths. And as opposed to this method, there is also another way to calibrate your Nomad machine where you jog the actual bit and not the little metal rod to the bottom left corner of your stock, and then you get a piece of paper and you essentially drag it until the paper is tightened, and then from there you'll set your X, Y, and Z to 0, and that will be set as your work origin point. Another important note is that this is the Z probe for the Carvera machine. Similar to the bits, it just kind of automatically swaps it in and out, which is very convenient. Essentially the way this works is it has a little sensor with a laser on the bottom that whenever you click it down onto a surface, it'll automatically sense that something is there. So pretty cool technology from Carvera, very useful as I said, and does speed up the calibration process by a lot. Alright, so now we are going to be focusing on the controller and actual machining process. So as you can see here, I already secured my stock. This is crucial, and if you do not do this, you can really jeopardize your cuts and just the safety of the operation in general. So once you have your computer out and you connect to the controller, I connected via Wi-Fi, but you can connect to the Carvera via USB and Wi-Fi. So once you do that, you go and you have to upload your file. So I already uploaded the file we just downloaded onto our desktop. However, if you go to upload file and then click it on here. You just do it again. So click confirm when you want to upload your file, and it should load pretty fast because this is a pretty small file. So you want to close it, go to your remote, and it should be at the top once you download it. Then you want to download that onto your controller, where you can then see your final toolpath. And you can monitor this here to see if there are any issues. Everything seems pretty efficient here, seems pretty good, so nothing to worry about. As for the actual calibration process, we have a few different options here. So first we're going to want to set the Z probe, and so from here we can see our work origin. So essentially this is the gap in between the stock and what is going to be milled in the inside here. So our origin point, or our work origin, we're going to want to set adjacent to where our stock is, so we can just leave that at 0, 0. And as for the Z probe, we can configure this so that our stock is set in the right place, so that is pretty good. And then if you want, you can do the auto Z probe, but once you start the milling operation, it'll do it automatically anyway. Then next you want to look at the auto leveling. This is essentially going to press down the Z probe so that it can level the stock and the spindle automatically. So obviously this is way too many points to press down on, and it's going to take way too long. So we're going to lower that to 2 points and 3 points each. And then press OK. And here you can see we have a much simpler path. If you want, you can even set one of them to 5 if you want it to be more accurate, but I just think it's fine like this. And then finally, we want to do our margin. This is already fine, as, like I said, we're starting from 0, 0, so nothing really to worry about here. But if you are going to have stock that is not in the bottom left corner, you do want to offset that accordingly. And then once you're done with all of those options, you can finally go and then click configure and run. And here we can see all of our options. You're going to want to turn on auto Z probe and auto leveling. So now once all of our settings are here, you can click run and finally start the machine. So as you can see here, it's going to drop the bit that I already put in for this operation back into its first slot, and then it's going to grab the Z probe. So I'm not going to show this entire process. However, once you get to this stage, you're going to want to just simply watch the milling operation and see any signs that there may be any strain or chances of an error during the print.